Hello, my dear children of class 11 science. Today we again do continue with the chapter as we have already done. Okay, some important topic in the last classes only, that is kinetic theory of gases. Okay, now today we complete this chapter. Okay, and especially in today's class we discuss one of the topic that is called gas laws from kinetic theory. You know, gas law means like Boyle's law, Charles' law, Avogadro's law. Okay, these are the laws that you have learned even in class 9. Okay, but this law can be even verified by kinetic theory of gases. That means this law is actually based on, these laws are based on, the kinetic theory of what? Gases. Okay, so to understand in detail about the explanation of gas law from kinetic theory, okay, we do one by one. Means we start first with Boyle's law. So first we do with Boyle's law. Now Boyle's law, as you have learned, actually it gives the relation between pressure and volume at a constant temperature. Okay. Now Boyle's law basically states that the product of pressure, so try to understand, the product of pressure and the volume of a given mass of gas is always proportional. I mean, they are always inversely proportional to each other. I can say that the product of pressure and the volume of given mass of gas is always constant, and this constant at constant temperature. Now, if the temperature remains constant, then the pressure and the volume are inversely proportional to each other. So that if pressure and volume are inversely proportional to each other, then their product, the product of pressure and volume, is always constant, and this remains constant at a constant temperature. Okay, that means according to Boyle's law, as you know, that the product of, let me just write the statement, the product of, okay, the product of pressure, okay, the product of pressure and volume, the product of pressure and volume of a what? Given mass, volume of given mass of a gas is always what? Constant. Their product remain constant, but this constant remain constant at what temperature? Constant temperature. The product remain constant at constant temperature. Now this is actually the statement of what? Boyle's law. Okay, so if this is the statement of Boyle's law, then from kinetic theory of gas also we can verify this statement of Boyle's law. Now to verify the statement of Boyle's law, okay, now we know, as for kinetic theory of gas, the pressure of given mass of gas, and basically this law, as you know, it is applicable for what gas? Ideal gas. So children, remember this part. Boyle's law, Charles' law, okay, Avogadro's law, or law of pressure, these are the laws, gas laws, okay, which are valid, or it can be applied only for what? Ideal gases. So according to what law? According to kinetic theory of gases, as you know, kinetic theory of gases, the pressure of an ideal gas can always express in terms of what? The velocity of the gas. Okay, so let me just write the relation. So according to kinetic theory of gas, the pressure, okay, the pressure of a what? Given mass, the pressure of a given mass of a what gas? Of an ideal gas. The pressure of given mass of an ideal gas is always given by P equals to 1 by 3 mn by B with mean square velocity. Mean square what? Velocity. Yes children, this is the relation that you have already learned. We have derived this relation also. Now P means the pressure of the ideal gas, which is equals to 1 by 3 m is the mass of each gas, okay, each molecule of gas, and is the number of molecules of the gas divided by the volume of the gas, and this is called mean square velocity of the gas. This is called mean square velocity of the what? Gas. Now basically mean square velocity means also called mean square speed. We can use the word speed of the molecules of the gas. So whatever number of molecules are there, they acquire the speed, and the speed of the gas is given by mean square speed. Okay. Now in the relation, if you see, okay, if I just do cross multiply with P and B, I write on PB equals to 1 by 3 mn with mean square velocity. So if I just take this B, this side, the left hand side, so PB, the product of PB equals to 1 by 3 mn mean square speed or velocity of the gas. Now this Mn is actually the mass of the gas. Mass of the what? Gas. And mass of the gas is basically what? Constant. So children, remember this, since Mn, in the relationship, Mn is the what? This is the mass of the gas. This is the mass of a gas, which remain what? Constant. Which remains constant. So if mass of the gas remain constant, then at constant temperature, see, this is very important. When you state Boyle's law, children, the temperature must remain what? Constant. Because Boyle's law can be stated only when the temperature remaining constant. So at a constant temperature, okay, let me write down, at a what? Constant temperature. At a constant what? Temperature. This mean square speed of the molecules also remain constant. Because mean square speed is directly proportional to temperature. When temperature increases, this square speed also increases. Mean square speed also increases. But if the temperature remain constant, means this mean square speed also remain constant. Which means in the relation of right hand side, this Mn is already constant. 3 is a number which is also constant. But at a constant temperature, if this quantity also remain constant, then their product on the left hand side also remain constant. That means at a constant temperature, the mean, you can note it down, the mean what? Square speed. The mean square speed of the molecules. The mean square speed of the what? Molecules. That is B bar square. Okay. Also remain what? Constant. I mean, this is the factor which remain constant. Remains constant. But remain constant only at constant temperature. Then the right hand side, this product on the right hand side remain constant. That means I write down therefore PB remain constant. Means this left hand side product will remain constant. Why? Since 1 by 3 Mn with mean square velocity or speed remain constant. So right hand side whole quantity remain constant, means the product, that is left hand side, also remain what? Constant. And this PB is constant as per the statement of Boyle's law, is the statement of Boyle's law. So according to kinetic theory of gas also, the Boyle's law is stated, and means it can be verified. That means this is which law? Boyle's law. So children, this laws is actually based on the kinetic theory of gases. So kinetic theory of gas clearly explain do the explanation of the different gas laws, and that gas law is, one of the gas law is called Boyle's law. Okay, so Boyle's law can be easily verified using kinetic theory of gases. Now we go to the next law, that is called Charle's law. So Charle's law can even verified just like your Boyle's law. Okay. Now to verify Charle's law from kinetic theory of gases, okay, let me just state what is Charle's law. As you know, you have learned in class 9 also. The Charle's law basically states that the volume of a given mass of a gas, is at a constant pressure. See, the volume of given mass of gas at constant pressure is directly proportional to the absolute temperature of the gas. Means volume and temperature are directly proportional, but this is true at a constant pressure. So I write down B is proportional to what? T. So mathematically B is the volume of the gas, T is the temperature of the gas. But this B is proportional to T at what? Constant pressure. Constant what? Pressure. And this is actually called Charle's law. Now this is the statement you learned, but children, this statement or the statement of Charle's law can be verified from the kinetic theory of gas. So in order to verify Charle's law from kinetic theory of gas, so we'll start with the pressure of a gas. The pressure of a given mass of gas, okay, of an what gas? Ideal gas. And this pressure of a given mass of ideal gas can be written in a similar manner, like I have done for what? Boyle's law. And children, according to kinetic theory of gas, the pressure of a gas, the given mass of gas, what gas? Ideal gas, is expressed by the relation, see, P equals to 1 by 3. Children, this is 1 by 3, Mn by B, capital B, with mean square speed of the gas. Now from this relation we can verify the Charle's law. But in order to verify this from this relation as the Charles law, so what I do, I'll make B as the subject. Okay, I'll make what? B as the what? Subject. So children, B, capital B, the volume of a gas can be even written as B equals to 1 by 3 mn by P and mean square speed. So I just interchanged between, I did the interchange between P and what? B. Okay. Now to write this B now in terms of temperature, in terms of what? Temperature. So what I usually do, I write this B in terms of the kinetic energy of the molecules of the gas. But to write kinetic energy, there must be 1 by 2. So there is 1 by 3 only. So what I do, in this relation, I multiply by 2 in the numerator and divide by 2 in the denominator. So there is already 1 by 3. So if I multiply by 2 in the numerator, I also divide by 2 in the denominator. Okay, so it will be now 2 by 3 into 1 by 2. So I just added 2 in the numerator and what? Denominator. Now it will be mn by P with what? Mean square speed. Now I just rearrange this expression and write out this way: 2 by 3 n, I write n by P. Now after writing n by P, I write this 1 by 2 now mn mean square speed of the gas. So just trying to write this B in terms of the kinetic energy of the gas, because you know this is kinetic energy. So 1 by 2 m B mean square speed is the expression of kinetic energy. But this kinetic energy is the what? Kinetic energy, average kinetic energy of one molecule of the gas. And we have done in the last class only the average kinetic energy of one molecule of the gas can be even written in terms of temperature by the relation. And the relation is, write down since average, okay, kinetic energy. So average what? Kinetic energy of one molecule. See, average kinetic energy of what? One molecules is actually nothing but given by 1 by 2 m B mean square, and this can be written as how much? 3 by 2 kT. So children, I am writing directly because this relation we have derived already. So average kinetic energy per molecule or one molecule of an ideal gas, which is this is the kinetic energy, and that can be written as 3 by 2 kT. And where K is a what constant? Boltzmann constant, where K is a what constant? Boltzmann constant. So now what I do, I replace this m1 by 2 mb is mean square speed, that is average kinetic per molecules or one molecule of gas, by this 3 by 2 kT. Okay, so now write down B equals to, there is already 2 by 3 into n by P. Okay, now this 1 by 2 m mean square speed I replace by 3 by 2 kT. So 3 and 3 cancel out, even 2 and 2 also cancel out. Now see the expression is coming, B equals to n by P, and this is K and what? T. Now this is the relation of volume in terms of pressure, temperature, and the number of molecules and the Boltzmann constant. But children, we are trying to verify what? Charles law. And Charles law can be verified when the pressure remains constant. So at a constant pressure, at a what? Constant what? Pressure. When the pressure remains constant, okay, then this whole quantity remains constant. This quantity means this whole quantity remains constant. This whole quantity remains constant, except the temperature will not remain constant. So at a constant pressure, N is always constant, Boltzmann constant is also a constant, P is a constant, then this quantity also remains constant. So at a constant pressure, I write down B is proportional to what? T. So that means if the pressure is constant, then for a given mass of gas, the volume is directly proportional to temperature. The volume is directly proportional to what? Temperature. This is for a given mass of gas. This is for a given mass of a gas. So for a given mass of gas, if B is proportional to T at a constant pressure, that we have verified from Charles law, and this verified from kinetic theory of gases, then this relation you can see is the relation of what? Charles law. That means, therefore, I write down B is proportional to T verifies what? Verifies what law? Charles law. So these are the two important, this is also one of the important law in case of gas equation. So gas law basically means Boyle's law, Charles law and all. So Boyle's law also be verified. The Charles law is also verified from the kinetic theory of gas. So this is the verification of Boyle's law and Charles law on the basis of kinetic theory of gas. Now there is another law to be verified, that is called Avogadro's law, and that you learn in the next YouTube video.